Here we have an incoming ball with an elastic collision with another ball of the same mass. Can you do the math to prove the outcome? Notice the total energy and the total momentum stays the same. Let's look at the center of mass motion. That stays the same as well. Try this one. Does the momentum before equal the momentum after? The masses are not the same, so this problem's a little harder. Here's an inelastic collision. They're going to hit and stick. Can you calculate the final velocity? Let's see what it looks like with the data. What's that center of mass doing? Stays the same, doesn't it? Well, here's another inelastic collision. Watch this one. Oh my, the momentum before and after was zero. Momentum is a vector, remember that. Okay, here's a recoil problem. One goes one way, one goes the other. If I gave you one of those velocities, would you be able to calculate the other? Where did the energy come from? The momentum is zero, but the energy is there. It's in the spring. The potential energy is turning into kinetic energy. What about the center of mass? You see, that's an internal force. You can't move the center of mass with an internal force. How about this one? A little bullet is going to shoot through a large object. Momentum still stays the same. Here we have an inelastic collision, but there's an elastic spring between the objects. They're going to hit and stick. Let's see what happens. Well, this would be like an atom moving into another atom in a chemical reaction. You now have vibrational energy. Here's another example. The momentum is zero, but the kinetic energy and the potential energy keep swapping back and forth. Now, my total energy is a little bit off here, and that's because of the computer round-off error. Now we'll try a problem in 2 dimensions. Here's the data. Let's see what happens. Oh, it's like pool. Let's take a look at that center of mass. The center of mass motion keeps constant. Now we'll see if the momentum stays the same. Momentum is constant. The total energy is constant too. This is a completely elastic collision. Can you do momentum in 2 dimensions? Let's trace the motion. You should be able to calculate the final momentum from this data.